Welcome to this Alan Talks Tech video. If you'd like additional information on my technology videos, please visit my wiki at alantestwiki.pbworks.com. So let's take a look first at LTE and Frequency Division Duplex. Basically, we use two frequencies to separate the uplink and the downlink. But unfortunately, a little bit of spectrum is wasted, as to separate out these two channels we need a guard band. So although this is, in terms of latency, one of the best technologies, it's perhaps not the best technology in terms of spectrum utilization. One of the other technologies you could use is Time Division Duplex. It uses the same frequency for the uplink and the downlink. So in terms of spectrum utilization, it's much more efficient. There is a guard period which allows the signal to arrive before transmission can begin. As you move away from the E node B, this guard period has to extend. So the overall latency can increase as the user or the UE moves further away from the E node B. It also requires some fairly sophisticated synchronization, as we are basically using Time Division Duplex. There's one slot for the uplink and one slot for the downlink. This technology, though, does give you some additional benefits, as the downlink, for example, can be customized. An additional period of time can be allocated to the downlink slot, as typically in many applications the downlink is going to require more capacity. So let's do a quick comparison between Frequency Division and Time Division Duplex. Frequency Division Duplex uses twice the amount of spectrum of Time Division Duplex. So in this case, Time Division Duplex is the winner. But Time Division Duplex has higher latency. This can affect, for example, some applications where TCP slow start can become a little bit of an issue. Frequency Division Duplex equipment, though, is more expensive due to the diplexer. The uplink frequency and the downlink frequency are different. So in this case, Time Division Duplex wins. The Time Division Duplex guard period increases with distance, and efficiency goes down due to the increase of latency. So in this case, Frequency Division Duplex wins. Time Division Duplex can dynamically allocate time slots for the downlink as required, so this improves overall efficiency. So in this case, TDD wins. TDD, though, can be more complex due to the synchronization requirements, so in this case, Frequency Division wins. But I think you'll find today most networks will tend to deploy Time Division Duplex over Frequency Division Duplex, although many carriers will in effect deploy both technologies. It's not typically an either-or situation. But what's next? In 5G, I suspect we'll be using true full duplex communication on a single frequency. Instead of using Time Division Duplex or Frequency Division Duplex that's used in the 4G systems today, 5G will use one frequency for transmit and receive simultaneously. This is typically not possible today with most RF devices, because on the transmit side, when you transmit a signal, for example, if I'm talking, that goes into the transmitter, it's going to be immediately picked up by the cell phone's receiver, for example, drowning out the receive signal from the E node B. However, technology is continually advancing, and now with advanced echo cancellation and suppression, the transmit signal can be removed from the receive side, basically removing the self-interference. This technology was first demonstrated a few years ago at Stanford University, and a lot of work was also done at Columbia University, where they basically miniaturized everything onto a single chip. This was a major breakthrough. Many of the developers actually refer to this technology as DUDE, downlink, uplink, decoupling. So although this technology is been around for a few years. It's still undergoing certain refinement and perfection, but I would expect to see it deployed in 5G systems by 2020. Welcome to this Alan Talks Tech video. If you'd like additional information on my technology videos, please visit my wiki at alantestwiki.pbworks.com.